Welcome to clickmyproject.com. Our product title is Spectrum Sensing Performance in Cognitive Radio Networks with Multiple Primary Users. In cognitive radio networks with multiple primary users, the secondary users are often located outside the sensing range due to the aggregated interference caused by the primary user. Due to this condition, the probability of spatial fault alarm and the performance of the cognitive radio network decreases. By adopting energy-based sensing for each secondary user, we are going to characterize the interference caused by multiple primary users located outside the desired sensing region. Initially, we are going to calculate the number of primary users and secondary users in the spectrum region. Usually, the secondary users are always outside the spectrum range and causing the primary users to have the aggregate interference level. By the formulation of area of secondary users and primary users for a throughput in cognitive radio network, the calculation of primary users and secondary users in the spectrum region is being calculated. By aggregating the value of interference level by the primary user due to secondary users have been aggregated and formulations have been made. The aggregate performance of primary users with secondary users shows the possibility of false alarm and detection. The aggregate interference of secondary users with the primary users provide the probability of detection of the primary user within the spectrum region and the probability of false alarm being created by the secondary users with reference to the primary users. In the spectrum sensing performance analysis, we are going to analyze the spectrum allocation for the proposed system, that is energy based sensing, and the normal procedures of gamma distribution function and normal distribution function. The energy based sensing provides the probability of detection and false alarm for the secondary users with the primary users. With the formulation of probability of detection and probability of false alarm, we are going to calculate the energy that is being attained by the secondary users in the spectrum region. The gamma distribution function and the normal distribution function provides the probability of detection and false alarm probabilities. Comparing the gamma distribution function with the normal distribution function with the energy based sensing of our proposed method, it is found that our energy based sensing method has attained the probability of detection and probability of alarm with less value compared to the gamma and normal distribution function. The mean and variance of the false alarm values are being calculated and their probabilities of detection are being found. After the calculation of probability of false alarm and probability of detection, it is impaired with the channel fading effect. In the fading of channels, the number of samples that are being transmitted through the cognitive radio network is being measured. By passing our signals through the Rayleigh fading channel, our impact of channel fading has been estimated and the throughput of the cognitive radio networks are being analyzed. In the energy threshold calculations, the value of threshold value inside this region, spectrum region, and outside the spectrum region are being calculated and energy threshold values is being provided. By taking both the values in comparison with the throughput of the cognitive radio network, it is shown that with the impact of Rayleigh fading and the energy threshold values, the probability of detection and probability of fault alarm for our energy-based sensing of secondary uses has been drastically decreased, and the gamma distribution function and normal distribution function for the sensing of secondary uses has been increased. This shows that our proposed method, that is energy based sensing of probability of detection and false alarm, has provided that it has given a maximum throughput in the cognitive radio network. By proposing a simple decision threshold criteria, the spatial false alarm can be neglected. On consideration for the future network, it is shown that the throughput achieved by the secondary uses decreases as the path loss coefficient increases. Open the MATLAB simulation software and run the program. The first graph implies the probability of detection and probability of false alarm values with the decision threshold with the power transmission unit value equal to 30 dB. In this graph, the simulation PD values and theoretical PD values and the simulated false alarm values and theoretical false alarm values are being obtained for the power of primary users equal to 30 dB. The simulation values and theoretical values are incoherent with each other, shows that the simulated PD values are nearly with the theoretical PD values. From the graph, it is inferred that as the value of decision threshold increases, the value of probability of detection and probability of false alarm value decreases. The next value of graph is plotted between probability of false alarm and probability of detection and between decision threshold frequency. Probability of detection and probability of false alarm values are obtained for the power transmission power of primary users with the value of 20 dB. It is inferred that the simulation probability of detection and theoretical probability detection values are incoherent. Probability of false alarm value are incoherent. It is inferred from the graph that as the value of decision threshold increases, the probability of decision and the probability of false alarm value decreases. The next graph is plotted between probability of detection and probability of false alarm value with different value of ns samples. It is inferred from the graph that the blue color lines indicate the probability of detection and the red color lines indicate the probability of false alarm. The values are plotted between PD values and PF values for the path loss and fading and the window shading. From the graph, it is being inferred that the probability of detection values increases and reaches 1 as the number of sample value increases, and from the probability of false alarm value downs to 0 as the number of sample value increases. The next graph is plotted between probability given for the different alpha values and the different level of protection. From the graph, it is inferred from the probability of detection value increases and saturate to 1 after the number of sample values falls to 40, and from the probability of false alarm value, the probability value downs to 0 as the number of sample value increases. The graph is plotted between SSU and probability of detection given the condition that the throughput achieved by the secondary users given that the number of primary users are active within the sensing region. The alpha 5 values are being processed for the probability of detection and corresponding sensing value of secondary users are being